Hello viewers, I would like to find the mean and the variance of this geometric distribution. Now to do this, I have that my expectation of x to be equals to the summation of x multiplied by the PMF, which is p 1 minus p to the power of x minus 1. Now rewriting this given equation, I'm going to have factoring p out, p summation x 1 minus p to the power of x minus 1. Now, there's something I'm going to do. I'm going to work on this alone for now. Then I can say that let s be equals to summation of x 1 minus p to the power of x minus 1, where my x equals to 1 to infinity. Now, let's plug in this value of x. Don't forget my support. Okay, my support of I equals to 1 to infinity. Now, my s is going to be, when you plug in x to be equals to 1, I'm going to have 1 plus, when x equals to 2, you're going to have 2, 1 minus p. Okay? With x equals to 3, you're going to have 3, 1 minus p squared, continuously like this. Now, this is going to give you the first equation. Now, you're going to have the second equation by multiplying it by 1 minus p times s, that is multiplying s by the coefficient of 1 minus p. So here you have the first term to be 1 minus p plus the second term to be 1 minus p squared plus the third term to be 3, 1 minus p cube, continuously like that. Now, next is to say equation 1 minus equation 2, that is s minus 1 minus p s. And this is going to be 1 plus 1 minus p plus 1 minus p squared plus 1 minus p cube plus continuously. Now, here you're going to have ps, if you simplify the left-hand side, to be equals to, looking at this is geometric series, and this can be done using the sum to infinity. And the sum to infinity, you can use the term a over 1 minus r. A is 1, r is 1 minus p. So now we have our ps to be a, which is 1 over 1 minus p. Now here we have ps to be equals to 1 over p. Now simplifying for s equals to 1 over p squared. Now coming back, you can see from here, okay, you can see that from here, our expectation of x is this, okay. So my expectation of x equals to p, replacing this with s, so you can have 1 over p squared, and your expectation is 1 over p. Now, to find the variance of x, the variance of x is expectation of x squared minus expectation of x all squared. Now, we've gotten the expectation of x, we need the expectation of x squared. Now, to get the expectation of x squared, we're going to use the same approach. Don't forget that expectation of x squared is going to be summation s squared times the PMF. What is the PMF of geometric? P 1 minus p to the power of x minus 1. Okay, now here we're going to have p, factoring it out, summation f squared 1 minus p to the power of x minus 1. Okay, now let s to be equals to this term. Okay, so s is going to be summation s squared 1 minus p to the power of x minus 1. Don't forget the range of x. x is from 1, 2 to infinity. Now, let's go the same way. So here my s is going to be, when s is 1, x is 1, okay? We have 1. When x is 2, we have 4, 1 minus p. When x is 3, we have 9, 1 minus p squared. When x is 4, we're going to have 16, 1 minus p cube continuously. Okay. Now, using the same approach like we use, multiplying s by coefficient of 1 minus ps. If you multiply by the coefficient 1 minus px, now we can have these to be 1 minus p, which is the first term, plus 4, 1 minus p squared, plus 9, 1 minus p cube, like this. Okay, now the same approach, which is equation 1 minus equation 2. Then we have s minus 1 minus ps. If you do this, you're going to have 1 plus 3, 1 minus p, plus 5, 1 minus p squared. Okay. Now, solving the one on the left-hand side here, this is going to give you ps equal 1 plus 3, 1 minus p, plus 5, 1 minus p squared. Okay. Now, there's something I would like to do. This 1 minus ps will be multiplied by coefficient 1 minus p. Why? Because that this given expression here cannot be solved using the geometric series. So I need to reduce the coefficients to make more sense. Now I'm doing the same thing here. I'm going to have 1 minus p plus 3, 1 minus p squared, plus 5, 1 minus p cube. Now, the next thing to do is to use the same approach by saying this term minus this term, which is ps minus 1 minus ps. And this is going to be 1 plus 2, 1 minus p, plus 2, 1 minus p squared, plus 2, 1 minus p cube, like this. Now, what can we factor out from this? Here we can see that here we have 1 plus 2, 1 minus p, which is common to the remaining terms. So let's factor it out. So we're going to have 1 plus 1 minus p plus 1 minus p squared plus a continuous term. Now, we can use the geometric series to simplify this. By using that, we can see that our a is 1, common ratio r is 1 minus p, and the sum is s equals to a over 1 minus r, which is 1 over 1 minus 1 minus p, which is 1 over p. Okay, that is the sum. So now, on the left-hand side, we're going to have p squared s to be equals to 1 plus 2, 1 minus p, multiplied by 1 over p. And here, we have this to be 1 plus 2, 1 minus p divided by p. Now, let's take this back into this equation. Okay, which is P times S. Okay, so this is going to replace it. Now, before we do that, don't forget that we need to make the S the subject of the formula here. And here, my S is going to be 1 over P squared. 1 plus 2, 1 minus P. So now, going back, we have expectation of S squared to be P times S, which is the same thing as P times 1 over P squared, 1 plus 2, 1 minus P over P. And here we have our expectation of S squared to be 1 over P plus 2, 1 minus P over P squared. Why? Because P cancel out one of these P. Now we've gotten the expectation of S squared, and recall that the variance of X equals to the expectation of S squared minus expectation of X all squared. So the expectation of X squared is 1 over P plus 2, 1 minus P over P squared minus 1 over P all squared. Okay, now finding the LCM, which is P squared. So P in P squared, we have P plus 2, 1 minus P minus 1. Now simplifying the numerator, we're going to have P plus 2 minus 2P minus 1 over P squared. And here we have 1 minus P over P squared, which is the variance. Thank you very much for watching. Please, if you find this very impactful, don't forget to subscribe. See you next time. Bye.